Hello students, we are ready with our next video. In this video, we will discuss the structural isolation of organic compounds on the basis of NMR spectroscopy, and I think it will be our approximately second last video in this NMR section. So let's discuss NMR structure determination of a different compound with the help of NMR spectroscopy. Before discussing the structural isolation of different compounds with the help of the structural data, we simply try to find out how simplest molecule will appear in NMR spectroscopy. Let's see how different simple molecule will appear in NMR spectroscopy. Suppose I start with methane. What will the spectra of methane? Methane spectra will be singlet, and it will appear somewhere between 1 and 2, singlet. Suppose if I ask you what will be the spectra of ethane, ethane will also be singlet, and in the same region where methane is found, we will found for ethane also for 6 protons. Intensity of this ethane peak will be higher because the number of proton in ethane is 6 and number of proton in case of methane is 4. So methane peaks will be less in comparison to ethane. Suppose I ask you what will the spectra of chloroethane. In case of chloroethane, the spectra will be, there will be two type of peaks. It will appear as a triplet, it will appear as a quartet, and quartet will have higher value in the range of approximately, we can say 3.1 approximately, and it will be approximately 1.2 K as per. You will observe peak for triplet. So we will observe peak for triplet 1:3:1 for triplet, and for this quartet we will observe around 3.1 K approximately. So we will observe quartet 1:2:2:1, and ratio of, you know very well that triplet will be higher because it contains 3 proton, so it will be of higher area of this will be higher in comparison to the CS2 because it contains only 2 protons. And separation between these lines, you know very well, are called coupling constants. Whatever the coupling constant, you will write the coupling constant in your spectra. Suppose I ask you what will the spectra of benzene will look like. Spectra of benzene, in case of, if you are given only simple benzene system, so simple benzene contain only one singlet, all 6 protons are same, so it will be a singlet in the range of aromatic region. Aromatic region is from 6.5 to 8. This is the aromatic region. So you will observe a peak in this region, somewhere in this peak region, a singlet peak for benzene ring system. Suppose I ask you to write the spectra of toluene. In case of toluene, the spectra will show you 2 different spectra and NMR spectra. One peak will be singlet for this methyl and one singlet for this, but in case of this 5 proton will show you singlet, in case of this 3 proton will show you singlet. So this proton will appear at approximately 2.1, so you will observe approximately 2.1 a singlet, and proton for 5 proton will show you a singlet in the aromatic region. Aromatic region is 6.5 to 8, so you will again observe singlet in the aromatic region for 5 protons. Ratio of 5 is higher in comparison to 3 because they contain 3 protons, it contain only 5 protons. Suppose I ask you what is the spectra of this paraxylene. Then again, in this case of paraxylene, you know number of proton environment are only 2, one associated with methyl proton and one associated with benzene ring system. So 2 singlet will be observed, one for this methyl and one for this benzene ring system. So methyl will be at approximately 2.1. So you will observe a very strong singlet because it contains 6 protons. So intensity of the peak will be higher in case of methyl proton CS2, CS3, and this in case of you will observe only in case of benzene ring system you are observing singlet for 4 protons. So area of this 4 will be lesser in comparison to 6. So these are simplest example of how simple molecule will look like. But we are moving towards difficult molecules with the help of spectral data, we will try to determine the spectra of some unknown compound with the help of the NMR spectral data. So we are ready with some example and some data of different compound, and we will with the help of data we will try to find out the structure of compounds. We are taking the simplest example first of all. Simplest C6H14. So we can first of all, if we have to determine the degree of unsaturation, so C6H14, so it is already 14, so degree of unsaturation is equal to 0 in this case. So unsaturation index in this case is 0, so this compound must be a saturated compound. Now data is that delta value is 0.8 for, and doublet is the nature of peak for 12 proton, 1.4 delta value, haptate is the nature of peak for 2 protons, 12 protons giving a doublet. It means your spectra will be somewhere like showing us a this type of pattern: CS3, CS3, CH, CH. The compound must be containing this type of moiety because it is showing doublet for 12 proton. So you can see here 3, 6, 9, 12, and it is neighboring is to CH, so it is doublet for 12 proton. So we have to count for 6 carbon. So we are already 6 carbon here, so we just have to join it. Now we see this doublet for 12 protons, doublet for 12 protons. For these 2 protons we will observe haptate for 2 protons, so 1.4. Delta value should be higher in case of this proton, and we are actually observing delta value higher for this proton. So this is the compound having this molecular formula. Now second compound is C3H7ClO. What is the degree of unsaturation? Degree of unsaturation, you have to take C3, corresponding H will be C8, H8. There is 1 Cl, so we have to decrease 1 H from it, so it will become 7. So 7 minus 7 divided by 2 is equal to 0. So this compound is also a we can say is also a saturated compound. Now after observing this saturated compound, it is also a example of a saturated compound. Now spectra you can see here, delta value 2 for pentate for 2 protons, 2.8 singlet for 1 proton, 3.7 triplet for 2 proton, 3.8 triplet for 2 protons. You can see here singlet for 1 proton. Always remember this, that singlet for 1 proton always indicate carboxylic acid. If delta value is very high, it indicate alcohol, it indicates phenol. So you are observing a singlet for 1 proton, it means there must be some OH group in a compound. Now you can see these two peaks are almost same, triplet for triplet. You observe this type of peak when we have this type of compound, CH2 neighboring to CH2, only then you can observe this type of peak. So what is the nature of peak? Doublet for 2 proton, 2 protons, triplet for 2 proton, triplet for 2 proton. So triplet for 2 proton, triplet for 2 proton. You will observe, so this must be a peak in your compound. Now one singlet for 1 proton, it means there must be some OH. I am writing OH on this part because OH, these two should be CH2 CH2 because we have to satisfy these 2 peak. Okay, now later on then we have the CH2C, this again pentate. It means this pentate means we must be having some CH2 with neighboring to CH2 and CH2. Only then this will show you pentate. So this moiety must be there. So it means this the actual basic structure compound should be CH2, CH2, CH2. Why I am writing this? Because pentate will come only when we have CH2 neighboring with CH2 and CH2, and these two CH indicate there must be some CH2 CH2 group. So these CH2 CH2 groups are there. Singlet for 1 proton always indicate, and we are also having oxygen here. So oxygen with one singlet for 1 proton always indicate phenol, alcohol. So we have this alcoholic group here. Now we are left with Cl. So just write Cl here. Now count the carbon, C3, 1, 2, 3, C3. Count the hydrogen, 2, 6, 7, 7, Cl, Cl, oxygen, oxygen. So this is the structure of this compound. Now compare. Now we have to justify our data also. So this pentate, this should give us the pentate, and pentate should be of least value. Is that the case? Yes, it is the case that pentate is having a least value because it is away from the oxygen, and value of these two are comparable because oxygen electron activity of oxygen and Cl are almost comparable. So we have observing almost comparable value for these two triplet proton. So it will show us a triplet, it will show us a triplet, it will show us a pentate, it will show us a singlet. So we observe 4 type of environment, and we are actually observing 4 type of environment, as you can see here. So the point you should remember here is that singlet for 1 proton, if oxygen is there, always indicate oxygen, or is there, always indicate alcohol or phenol or carboxylic acid. If delta value is very high, then carboxylic acid. Triplet always indicates CH2 in your compound. Pentate for 2 proton indicate CH2 neighboring to CH2 and CH2. So actual structure compound came out to be this. This is the actual structure of a compound. Now third compound, third is C3H3. C3H3Cl5. What is the degree of unsaturation? C3 corresponding proton will be C3H8. There is 5 Cl, so we have to decrease H by 5, so it becomes 3. So 3 minus 3 is equal to 0. So degree of unsaturation of this compound is again 0. So this compound will also be a saturated compound. So now as the data indicate, there is only 2 type of environment. Only 2 type of environment is there. Triplet for 1 proton. It means there must be some CH in a compound, and it must be neighboring to CH and CH. Only then this can show us triplet for 2 proton, triplet for 1 proton. Triplet for 1 proton can be observed only when we have this type of fragments. Now doublet for 2 proton, these two are, if these two are same, so if we are left with, we have to account for 3 carbon. So 3 carbon we have accounted for. We have to account for 3 protons. We have accounted 3 protons. Now we have to account for 5 Cl. So 5 Cl, for 5 Cl, write 2 Cl here, 2 Cl here and 1 Cl here. You will get the spectra of your compounds, justifying and satisfying all your equations, all your spectral data. You can see here, it will show us a triplet for 1 proton, triplet for 1 proton. As you can see here, it is attached to a 1 Cl, so value of this should be less. It is actually less. You can see here value is 4.2. It is less value, and these 2 Cl are, these 2 CH are equivalent, and they're neighboring to 1 CH. So these 2 CH will show us doublet. So we are observing a doublet for this, for 2 protons, and as you can see here, they are attached to 2 Cl. They are attached to 2 Cl. It means value of this proton should be higher. So this is actually the case that value of this proton is actually higher. So this spectra of the third compound is this. This structure of the third compound is this. These are more examples you can see here. We have 3 more compound. Data C3H5Cl3, delta value 2.2, singlet for 3 proton, 4.2 singlet for 2 protons, 3 carbon. This indicate what value, what information we get from this peak. This peak information we get is that singlet for 3 proton always indicate we have CH3 separated by just carbon. Only then we can have singlet for 3 protons. So it means there must be some group, but not the protons. Now we are left with only, we have accounted 2 carbon, as you can see here. We have accounted 2 carbon. So we are just left with 1 more carbon. So 1 more carbon will be there only. And we have this CH2 Cl. Only then we can have singlet for 3 proton, singlet for 3 proton. You can see here, singlet for 2 proton. So this proton will also show a singlet. Singlet for 2 protons. We can have this. This singlet will have a less value because in this case there is no Cl directly attached to the proton. But in this case, this singlet will have a higher value because Cl is directly attached to it. So this is the reason why singlet for 2 protons is having a higher value. It is having higher value because Cl is directly attached to it. So will it justify? Is it justifying the complete information? Let's see here. Singlet for 1 proton, singlet for 1 proton, singlet for 2 proton, singlet for 2 protons. You can see here value of this should be higher, and actually value of this is higher, as you can see here. So this is the compound structure. Second compound is this C4H9Br. What is the degree of unsaturation? C4 corresponding proton will be 10. It is containing 1 Br, so we have to decrease H by 1. It becomes 9. So 9 minus 9 is 0. So degree of unsaturation of this compound is 0, as you can see here. So this compound must be a saturated compound and contain 3 type of environment. And as you can see here, and the environment is almost alkane type of environment. You can see here, environment is almost alkane type. There is no aromatic part. Just by looking at the delta value, you can see whether compound is aromatic or aliphatic. So you can see that compound is saturated compound and compound is aliphatic compound because delta value are lesser. So in this case, we are observing 6 protons doublet. Doublet for 6 proton always indicate we have something like CS3, CH, CS3. Only then we can have doublet for 6 protons. Only then we can have doublet for 6 protons. So it indicates all this peak value always indicate the presence of isopropyl group somewhere. And now there are 4 protons. So we are just left with, so we have, as you can see here, we have accounted for 3 protons, 1, 2 and 3, and we are only having 4 carbon here. We have accounted for 3 carbon, as you can see here. So we can add 1 more carbon here. Then we have accounted all the 4 carbon, you can see very well. Now doublet for 2 protons. So if I write CS2Br, if I write CS2Br, this compound will satisfy all the information we are having here. You can see here doublet for 6 proton. It will be having, so we are having doublet for 6 proton. It will show us multiplet because it is showing coupling us with 6 proton and 2 proton. So this will show us a multiplet. So we are observing multiplet formation. It will show us the doublet formation. It will show the doublet formation. We are observing doublet formation. Out of these 3 protons, value of this should be highest. Doublet for 2 protons should be highest. So this is actually the highest value, as you can see here, because in this case this is directly attached to the electron withdrawing group Br. So this is the structure of a compound which satisfy all the information given in our problem. Then we have this compound C5H10O. These contain 3 type of proton environment. Let's find out what is the degree of unsaturation of this compound C5H10O. So C5H12, oxygen does not cause any decrease or increase, so proton will remain 12. So 12 minus 10 divided by 2 is equal to 1. It means that degree of unsaturation of this compound is 1. It means this compound must be containing some double bond. And second information is that just by looking at the proton chemical shift value, you can very well say that the compound is a aliphatic compound because there is no aromatic range value. So this is aliphatic compound with 1 degree of unsaturation. And one more thing, there is oxygen. So there is a quite possibility that it must be existing in the form of a ketonic structure. Now 6 proton doublet. So doublet for 6 proton always indicate presence of isopropyl group. So we must be having something like isopropyl group here. Now triplet for 1 proton. This always indicate we are having CS3 separated with some group which does not contain proton. So we have accounted 1, 2, 3 and 4. We have accounted for 4 carbon and we are having 5 carbon. So if I write here CO, so does it satisfy all the information? Yes, it satisfies all the information. Doublet for 6 proton, doublet for 6 protons. Heptate for 1 proton, heptate for 1 proton. Singlet for 1 proton, singlet for 1 proton. It is for 3 proton, it is for 1 proton, it is for 6 proton. So all information are satisfied. the highest value should be of this because it is tertiary in nature. Is it this case? Yes, it is the case that highest value is of 1 proton because it is tertiary in nature. This carbon is tertiary in nature. Therefore this proton should have a highest value. So we are having doublet for these 6 proton, doublet for this 6 proton in the range of 0.95, and we have this haptate for 1 proton, highest value 2.43. Singlet for 1 proton always we have in the range of 2.1, 2.2. So we are having 2.1 singlet for 1 proton. So this is the structure of this compound. So we are ready with more examples. You can see here C4H7BRO. This is information, the spectral data. 2.1 singlet for 3 proton, 3.5 triplet for 2 proton, 4.4 triplet for 2 protons. It means, as you can see here, almost aliphatic region. There is no aromatic compound in this case. So just find out what is the degree of unsaturation. C5H7BRO, C4H10 will be the corresponding proton value. It is containing 1 Br, so decrease this by 1. So 9 minus 7 divided by 2 is equal to 1. It means this compound contains 1 degree of unsaturation. It means this compound must be containing 1 double bond in its structure. As you can see here, it containing oxygen, so most probable it might be containing double bond in the form of CO. You can see here this value, singlet for 3 proton always indicates something like CH3 with some group, and I think some group is that, suppose I think group is CO, suppose I say group is CO. Only in that case you can observe singlet for 3 proton. This is the case. Now triplet for 2 proton always indicate CH2. So we have accounted for 1, 2, 3, 4. So we are having 4 carbon, and we have already accounted for 4 carbons here. So we are just left with 1 Br. Suppose I write Br here. Let's find out whether it will satisfy all the condition here. Singlet for 1 proton, triplet for 2 proton, triplet for 2 proton, triplet for 2 proton, triplet for 2 proton, and value of this should be high. Value 1 it should be high. It is very much high, and this singlet. So this is the structure compound containing 1 degree of unsaturation in the form of CO. Now we are having C8H10. C8H10. There is no oxygen, no nitrogen, and no halogen. What is the degree of unsaturation? C8H18. C8H18. So 18 minus 10 divided by 2 is equal to 4. So this compound must be containing 4 degree of unsaturation. And as I have already told you that for 4 degree of unsaturation always indicate that compound must be containing some benzene type of structure. So as they indicate degree of unsaturation is equal to 4, it means that compound must be containing some benzene type of structure. So if I write benzene here, okay, triplet for 3 proton and quartet for 2 protons always indicates, as I told you in the initial classes, always indicate ethyl group. So we have accounted for 6 carbon here. We are left with 2 more carbon to count for. So if I write ethyl here, CH2, CH3, all 8 carbon will be justified. So we have all accounted for the 8 carbon. This is very important information. You should keep this in mind, that proton aromatic range, singlet for 5 protons. Singlet for 5 proton aromatic range always indicate monosubstitution. If it was disubstitution, in that case you will observe 4 protons and some nature of peak. But singlet for 5 proton always indicate monosubstituted benzene ring system. So it is the case, monosubstituted benzene ring system. So let's see whether it justify all the information. So singlet for 5 protons, singlet for 5 protons. We have a quartet for 2 protons, quartet for 2 protons, triplet for 3 proton, triplet for 3 protons. Quartet value should be highest out of these two, and it is actually the case because it is attached to the benzene system. So this is the structure of compound. Now we have C10H14. C10H14, what is the degree of unsaturation? C10H22. So 22 minus 14 divided by 2 is equal to 10, 22 minus 2 is equal to 8, 10. Degree of unsaturation is equal to 5. Degree of unsaturation is equal to 5 here. 5 or 4 here. It is 8 and 8. C10H14. So 10, 20, 22. 22 minus 14 is equal to 8. I'm sorry. 8 by 2. So degree of unsaturation is equal to 4. It means again this compound is benzene type compound. So this compound must be containing some benzene structure in this structure. Benzene in this structure. So if I write benzene here, once you write benzene, you account for this 6 carbon atom. And again, very important information we are getting here. Singlet for 5 protons, it always indicate monosubstitution of benzene system. Remember very clearly that singlet for 5 proton always indicate monosubstituted benzene system. So we have singlet for 5 protons. Okay, what is the second information? Second information is 9 proton singlet, and this is also again very important. This is also very important information. 9 proton singlet is always indication of a tertiary butyl group. So we have a tertiary butyl group. So these two information are very important information. Singlet for 5 protons in case of aromatic ring system always indicate monosubstitutions, and 9 protons singlet always indicate tertiary butyl group. Always indicate tertiary butyl group. You should keep this in mind. So this is the structure of a compound satisfying all the informations. Okay, more examples here. C9H10. C9H10. What is the degree of unsaturation? C9 corresponding H will be 20. So 20 minus 10 divided by 2 is equal to 5. So degree of unsaturation in this case is equal to 5. In this compound, degree of unsaturation is equal to 5. It means that this compound must be containing at least one benzene system plus one additional degree of unsaturation. So we have information here. Aromatic range, you can see here aromatic range 4 proton singlet. It means we have a benzene system with di substitution. Only then we can have 4 protons in case of singlet system. So we have a aromatic system with di substitutions. So I write benzene here. Once I write benzene, I have accounted for 6 carbon. I have accounted for 6 carbon. I am just left with 3 more carbon to account for. So you can see here 2 protons give you pentate and 4 proton give you triplet. How it is possible? 2 proton giving you pentate and 4 proton giving you triplet. Something like this. 2 proton giving you pentate. Something like this it should be observed. Only then 2 proton can give you pentate, and these 4 proton can give us a triplet. Only then this. So I think this type of moiety must be present in our this benzene system. So if I have to count this, accommodate this here. So I will write this as this CH2, CH2, and CH2. Only then the complete information will be satisfied. Degree of unsaturation become how much? It become 5. As you can see here, 4 due to benzene system and 5 due to this ring system. And again, these 2 proton, 4 proton will show coupling with this to give you a triplet. So triplet for 4 protons. So this is the information. And we have this pentate for 2 protons. Pentate for 2 protons. This is this information. And out of these, the triplet should be having high value. Because it is close to benzene system. Is it the case? Yes, it is the case that it is closer to benzene system. Therefore, it is having a higher delta value. So this is the structure of this compound. satisfying all the information. Second information is C10, C14, H14, 2.9 singlet 4 protons, 7.1 singlet 10 protons. What is the degree of unsaturation? C14, H14, C14, H30, then 30 minus 14 divided by 2 is equal to 8. So degree of unsaturation in this case is 8. It means that this compound must be containing at least 2 benzenic system. This compound must be containing 2 benzenic system. Only then degree of unsaturation can be equal to 8. So as you can see here, singlet for 10 protons. How singlet for 10 protons are possible? If 2 benzenic system are possible. It is possible if we have a 2 benzenic system and 2 benzenic systems each are mono substituted. Only then this is possible that we have a singlet for 10 protons. So if you write this, so we have this benzenic system. We have this benzenic system and both of them are mono substituted, as you can see here. Then we have singlet for 4 proton. How it is possible? Singlet for 2 proton possible only when we have CH2 neighbor to CH2 and there is no other neighbor. So it means we have to write CH2 neighbor to CH2 in this way. Only then the complete information will be satisfied. You can see here now. Singlet for 10 protons, singlet for 10 protons, aromatic range. Singlet for 4 protons, singlet for 4 proton, aliphatic range. So this is the structure of our compound. Now we have this another compound, C10H14. C10H14. What is the degree of unsaturation here? C10 corresponding H for alkane is H22. So 22 minus 14 divided by 2 is equal to 4. So this compound must be containing 4 degree of unsaturation. It means it must be containing at least 1 benzenic system. What are the other information? Important information is singlet for 5 proton always indicate mono substituted benzene system. So we have to write benzene, and we have to write benzene as a mono substitution. Now another information, 6 proton doublet and 1 proton multiplet always indicate isopropyl group. As I told you, this is a very important indication of an isopropyl group, and we have doublet for this 2 protons. So we have isopropyl group CH3, CH3, CH. So we have accounted for 6 and 3, 9 protons. We are just left with 1 more carbon. We have accounted for 9 carbon. We are just left with 1 more carbon. So 1 more carbon can be here. So if I write it CH2 and join them, in that case the complete structure will be satisfied. It will show us doublet for 6 proton, doublet for 6 proton. Then we have this multiplet for 1 proton, because it is showing coupling with this CH2 and CH3, multiplet for 1 proton. We have doublet for 2 proton, doublet for 2 protons. Out of these 3, it should have a highest value. It is having the highest value, as you can see here. And singlet for 1 proton, it indicates aromatic system with mono substitution. So this is the structure of a compound. Some more example here. C8H10 information, 2.1 singlet for 6 proton, 7.1 singlet for 4 protons. So what is the degree of unsaturation here? C8H10. So C8H18. So 18 minus 10 divided by 2 is equal to 4. So this compound must be containing at least a 1 benzene system. But we are having a benzene ring with 4 protons. Singlet for 4 proton always indicated. You should remember this very important point. This is a very important point. You should note this, that singlet for 4 proton always indicate disubstituted benzene ring system. So benzene must be disubstituted. And second information is that we are having a singlet for 6 protons. It always indicate that we must be having some a methyl group. Only then we can have this type of information. So if I write methyl group on the para position, only then we can have, clearly we can have two environment only. So this structure satisfies all the information. If you write methyl on meta position, write on ortho position, they will not give you ideally two environment, but when you write methyl on para position, they will give you ideally two environment only. So 4 proton singlet always indicate di-substituted benzene system, and 6 proton singlet always indicate methyl and methyl. So this is the structure of our compound. C6H10O2, C6H10O2. What is the degree of unsaturation? C6H14, 14 minus 10 by 2 is equal to 2. It means that this compound must be containing 2 degree of unsaturation. It means this compound is not an aromatic compound, this is an aliphatic compound. This contains 2 type of proton environment. You can see here singlet for 3 protons, and we are having 2 degree of unsaturation with 2 oxygen. So you should note this in mind, that 2 degree of unsaturation with 2 oxygen indicates somehow we should have something like 2 CO group. And we are having singlet for 6 proton, always indicate we are having CS3 neighbor to CS3, CS3 neighbor to CO, so that no coupling is possible. Only then we can have singlet for 6 protons. And we are having CS4, 4 protons, we are having singlet 4 protons. If I write here CS2, CS2, only then we can have 4 protons giving us a singlet. So this compound satisfy all the information. It will show us singlet for 6 proton. So singlet for 6 protons we are observing. Singlet for 4 protons, singlet for 4 protons we are observing here. So this is the compound satisfying all the information. Now this is the last example, C4H8O2. What is the degree of unsaturation? C4H8O2, C4H10 is the aliphatic alkene, should be there. So 10 minus 8 by 2 is equal to 1. So degree of unsaturation is, in this case, is equal to 1. So this compound must be containing 1 degree of unsaturation. It means, and it is also containing 2 oxygen. So it means at least 1 CO must be present in this case. Okay. Singlet for 3 proton always indicates CS3, and there must be CO. Only then we can have singlet for 3 protons. Then we have, this is the important pattern. You can, as I told you many times before also, triplet for 3 proton and quartet for 2 proton always indicate ethyl group. But we have to account for 1 more oxygen, because there is 2 oxygen. So we have to account for 2 more oxygen, 1 more oxygen. So this should be the actual structure. This is the actual structure compound. Singlet for 1 proton, 3 proton. This is 3 proton. Quartet for 2 protons. Quartet for 2 protons. Triplet for 3 protons. Triplet for 3 protons. And this should have the highest value because it is close to the oxygen, and actually this is having the highest value close to the oxygen. So this is the structure of a compound. So by doing all these example, I'm sure that now with the help of NMR spectroscopy, and when you're given the NMR spectral data, you can find out the structure of different compound, different simple compound, because it is in a syllabus, it's just simple compound we have to discuss. So this different simple compound you can, structural elucidation you can do effectively if different compound data are given to you. So I think it must be clear to you. So we will meet in the next class. Thank you.